So in today our class we'll talk about Kubernetes. Like in previous cases, I didn't prepare this presentation by myself. I took this presentation from I don't know this guy, but he is from Google. You see, yes, it was presented in Advanced Spark and TensorFlow meetup in 2017. But I will use this presentation from this guy to explain you a few ideas, but examples will be mine. So at the first I mention the author of this presentation, but it's not very important for our class. The question for us is only know how to use it and in what way we will use it. So we have what is Kubernetes. You maybe don't know what is Kubernetes, but usually in practical life you will meet this word. This is technology which is open source, which was developed by Google and supported by Google now. It is based on large experience of running containers at scale. It was designed internally in Google. It's high efficient. Has more than 1,000 contributors, so this technology is rather important for industry and widely used in multiple applications. Allows you to deploy and manage applications declaratively. High level overview of it. We have multiple users. We have master node, which provides API server and scheduler. We also have API request or CLI or UI. We have kubelets which are running on the nodes. Main concepts of Kubernetes. What are the main concepts of Kubernetes? At first, we have container. It's some sealed application package, like Docker, maybe you have heard about it. We have pod, small group of tightly coupled containers, example content syncer and web server. We have controller, a loop that drives current state toward desired state, example replication controller. We have service, set of running pods that work together, example load balance backends. So the main idea is container. We have this idea in Linux operating system, in a low level, in LX containers, in Docker technology, and we have pod, which is small group of tightly coupled containers. So we tightly coupled containers. Yes, here we have controller and we have service. What is a pod? Pod are the atom of scheduling and scaling. You see that in one node, it's physical node. So at first I move back here, and you see that we have multiple nodes because we deploy our application in Kubernetes, and this is Kubernetes cluster. So one node of it, we have some volume. We have we can ingress some ports, and you see that each port has its own IP address. Ports may contain one or more containers and attached volumes. So node contains containers. And sometimes a pod can contain only one container. Usually we will use this option, but you can have option when in one pod you have multiple containers. It's also possible. It depends on your configuration and your needs. What is a Spark? About Spark we talked about previously. Yes, it's a used process in many kinds of workloads, for batch, for interacting, for streaming, processing. Lots of organizations already run their serving workloads in Kubernetes, and we can provide better resource sharing and management when all workloads run on single cluster manager. So what about Spark Standalone on Kubernetes? We can set up one master controller and a worker pods in a standalone cluster on top of Kubernetes, according to some manual, which is described here. We can provide resource negotiation. Yes. We have available only FIFO scheduling. And it's not don't have a robust authentication and authorization mechanism. We can have Spark external cluster backends like Yarn, Mesos, but Yarn I will not suggest you to deploy by yourself because it's too complicated. Better to use for this purpose HDP platform, Hadoop, or maybe Cloudera. Mesos is also a bit complicated to deploy by yourself, but maybe for testing purposes in your local machine, standalone mode will be suitable, but it's not secured well. So take into account this moment. And now we move forward. We can run Kubernetes client and cluster mode. Kubernetes provide and support Spark nowadays. Cluster mode is can be used. You see that we have some URL K8S. This abbreviation means Kubernetes. Kubernetes. Why K8S? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. K. Yes. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So we put here 8 and we have K and S. That's why Kubernetes. As a cluster scheduler backend, so it's easy to remember this protocol. We have Spark can talk to Kubernetes cluster directly, so scheduling of tasks, prioritization, and etc. can be done directly. So Spark understands what is a Kubernetes and can work with it, and run driver and executors in a Kubernetes. Maybe you remember, but executors are some containers which contain parts of our program which will provide data processing in different modes. Spark cluster mode, each application gets its own executor process. Yes, executor process. Tasks from different applications run in different JVMs. So one JVM per one application. And executors talk back to driver and run tasks in multiple threads. So we have rather good efficiency. Nowadays we have some support of it. It's because it's from a developer from Google. But what about Kubernetes? Kubernetes provides REST API. Also, we have Kubernetes Java client if you want to make REST calls, and allows us to create watch, delete pods and higher level controllers from Scala Java code. Because usually when you're working with a Spark, you're using Scala or Java. Also, it could be R or Python, but the most efficient is Scala or Java. And also we have a large number of multiple parameters here. And what we will do now, we have dynamic executor scaling possibility. Yes, so replica set could be created. So Spark knows how to intelligently scale down. Replica set can do it. Okay, few solutions we have for this option, but maybe it's too complicated for us. Let's move to some demo, yes, and let's try to run. Let's try to run our application. So what I will do, at first I will start our Minikube. I'm starting my Minikube. For this purpose I will run Minikube. Minikube is one of the implementations of Kubernetes. And you have to remember, but Minikube you can use by yourself in your own computers to try Kubernetes, because installation and configuration of complete cluster is a bit complicated for you. That's why I suggest you to run your system with the Minikube. You can put here, for instance, 8 GB of memory, 4 CPUs. We start it. I start Kubernetes. Minikube is, and again, Minikube very comfortable to run, to start with it. So it's starting. Internally it's starting for you virtual machine. Start or for you or Docker images or virtual box. So with this command you see that it takes some time, but it allows us to run it. So we have moving files into cluster. It's starting, and for you, if you're using Windows, because usually you're using Windows, I suggest you to look at this URL, and this URL explains you how to run Kubernetes on Windows. Minimum system requirements and what you have to do, how to configure it and how to install it. And only the commands also available here. So you see we have Minikube pause, we have start, and we have another commands. So let's continue and let's analyze another options. What options do we have? Another options. We can look. Yes, it started. It's already started. You see. Now we can do the next. We can run a command which called Minikube dashboard. At first, let's check it started or not. Running. You see it's running. So let's also, I forgot to tell you that we have command kubectl, and we can use this command to run some containers and manage our cluster. You see that we have kubectl get all, get some basic information about our cluster. You also see that we have already run our Spark, yes. So let's do the next. Let's run Minikube and run with dashboard, because at the beginning maybe it will be the easiest way to start with it. And it will start for you web UI. You see web UI, it's your local web UI. And in this web UI you can manage it, you can look it, check it, and etc. So namespaces, you have them here. You have nodes. You have some volumes, persistent volumes, which you have here. You have roles, multiple roles. You have storage classes. Now by default we have standard. And we have pods, multiple pods. We have Spark. We have one master and two workers. Master 0 and worker 0, worker 1. We can click on it and see details about it, how it running and where it running, IP address. I emphasize that this is internal IP address, because internally cluster communicates with another, with other pods and other containers through these IP addresses, because it has internal network. Usually you don't have a network, you don't have by default you don't have access internally. You have to provide access to your application. So Minikube, we have this application started, and now what I will do. So first your task will be try to install Minikube and configure it. Try to start hello world application inside it, because it's rather simple, but it's rather important to understand how it works and how to start this application. In manual which I sent for you, you can find this out. You see Minikube start, kubectl get, and dashboard, which you saw before, and also deploy applications, how to deploy hello Minikube and etc. And you will get some application. Also you have you expose some port, this port externally. You can get some information about this service. And you are using port forwarding, because internally your application is running in port 8080, but you cannot access to it. If you want to get access by localhost 7080, you should do this command, kubectl port forward. How it so now load balancer, if you want to make it, very simple. I told for you about this before. And if you want to create some tunnel, you can run this. When you decided to stop developing your application because it consumes too much resources, indeed, too much memory and other resources, you can stop it. Also, you can delete all, and you will delete all virtual machines, and you can start where you want from. So this is how looks like Kubernetes. please try to play with it. Later we will continue with Spark deployment and deployment with the application into Spark. In general, it's rather simple. It's rather simple because if I run here, oh sorry, at first I should do this. I run port forwarding. I showed for you before, and now I'm trying to access this port. Yes, we have here our cluster. We get access to our cluster. So